Okay, let's move on. Number 9, we've got to answer the question about whether or not this is growth or decay. And since our factor is bigger than 1, it's going to be a growth situation. And in this second one, we know that the factor is 25. We know it was decay. The percentage taken away, or the value taken away from 1, is how we deal with decay. Remember that decay is 1 minus, growth is 1 plus something. And so we always put that rate right here. It's either 1 minus the rate or 1 plus the rate if we're dealing with a decay, or 1 plus the rate if we're dealing with growth, 1 minus if we're dealing with decay. So if the factor is 0.25, the rate must have been 0.75 or 75%. Must have been taken away. Growth is 1 plus. The rate is how we get the factor, so we must have added 40.4 or 40% for number 11. And then in number 12, let's see, we've got a decay, and we want to reduce it by, in this case, we know that it's reduced by 0.25. 25% is 0.25, so the factor in our equation would be 0.75. Let's see, you decide to start a garden at your house and plant black-eyed Susans. The next summer you noticed that the flowers had reproduced significantly, and you wrote the following equation: n equals 5 times 4 to the t. N represents the number of flowers after time, t, and years. How many flowers did you plant in the first year? I would take different answers with this, because some people said, well, you know, if I said at the start, I think this would be more clear. In the beginning of the first year, it would have been 5. Now, if you put 1 in there, it would have turned out and told you that it was 20. But that would be at the end of the first year. Like in the beginning, we started out with 5. What's the growth factor of black-eyed Susans? It's 4. They are, can we spell this? Quadrupling? Wow, you don't have to spell that. And then how many flowers will be in the garden after the 4th year? 5 times 4 to the 4th. What do you got? 1280? Yep, it seems like a lot, but if you've got a big garden, you know, it's probably just filling it out and making... Yeah, this, I think it makes more sense to, did you plant the first year? Maybe I should have said at the start of the first year. You know, in the beginning, before, you know, how many did you start with? I started with 4. Yeah.
So say if it's like real, so like you plant 5 and it starts quadrupling, how does it, do you plant that much?
No, what, like the seed pods just kind of spread around. You know, like that's nature stuff. You know, the seeds themselves kind of spread around. The next year, more come up and more come up. You ever seen that happen around? Think wildflowers, because that's kind of the way the black-eyed Susans will grow, is if you don't pull them out, they just keep getting bigger and bigger and bigger. At noon, a pump starts emptying a tank of water at a constant rate. How much water was in the tank before noon? The starting value here was 2,700. So I'm going to assume this is in gallons, because it goes on to talk about gallons. And at what rate is the tank being emptied? It's going down 300 gallons an hour. And we know that because of the minus 300 T. T represents hours. Let's take a second to put a graph of it together. I think if I go by, let me see, maybe I'll just go by 500s. What the heck? 500. Actually, I'm going by 250s, but I'm marking every... You went by 300s? Okay. Your graph should still be like a straight line relationship when you get done. This would take me to 3,000. And after 1 hour, how long does it take you guys? When is it empty? How many hours does it take to empty it?
9.
Does it?
Yeah.
Okay. So this is going to be my gallons of water. This is going to be my time in hours. And I started at 2,700, and then all I got to do is subtract 300 every hour. So after an hour, there'll be 2,400. After 2 hours, there'd be 2,100. Then I'm going to go down to 18. Then I'm going to go down to 15. Then I'm going to go down to 1,200, 900, 600, 300, and you guys said, 300 would be about right there. And then you guys said that it would be empty by, you were exactly right, it'd get down to 0 9 hours later. And I would definitely connect this with a line simply because the water is, in between the hours, it's still going to be running out. I'm going to just try to keep going. How many hours would it take to empty the tank? 9 hours. So you could even solve this, like when is the tank at 0? And you could solve this equation. If I take 2,700 away from both sides, we could justify it this way. Negative 2,700 equals negative 300t. If I divide by negative 300, t is 9. When does it empty out to 0? All right.